Hey students, this is lesson 9.5, dilations. We're going to learn how to understand dilation images of figures. You can go ahead and do this review and check back with your answers. All right, a dilation. Here's some key concepts. A dilation with center C, right there, and scale factor n. N will be greater than 0 is a transformation with these two properties. The image of C is itself. For any other point R prime is on CR, and CR prime is equal to n, the scale factor, times CR, or n equals CR prime divided by CR. The image of a dilation is similar to its pre-image. For a dilation of triangle PQR with scale factor 2, CR prime is equal to 2 times CR, using that scale factor. All right, so for triangle A prime, B prime, C prime is a dilation image of triangle ABC. The center of dilation is the origin, which I think is right there. So point 0, 0 is our center. Center is 0, 0. Is a dilation an enlargement or a reduction? What is the scale factor? So we're going to need to figure that out. We just have to look at our image and our pre-image. Our image is A prime, B prime, C prime. Our pre-image is ABC. Since our pre-image is larger than our image, we are going to say that this is a reduction. And that's because our image is smaller. All right, now we need to write down a couple points here to figure out the scale factor. Let's use, I think it'd be easiest to use these points up here, B and B prime. It looks like B, the coordinates of B are 4, 5, and the coordinates of B prime are 2. And it looks like, that one might be a little bit hard to tell. Maybe we should use, let's use A and A prime, see if those work out better. Or we could use, let's use A and A prime. A, the coordinates are -6 and 2. And then A prime, it looks like those coordinates are -3, 1. So let's write those down. There's our center, 0, 0. A is -6, 2. And A prime is -3, 1. All right. Now to figure out our scale factor, let's call that n. That's our scale factor. What we can do is just take our center and one of the points and find the distance from the center to A prime, and then we're going to divide that by the distance from the center to A. So, and that comes from our concepts earlier. So CA prime over CA. In this case, the C stands for the center, not the vertex C. So CA prime, we're going to use the distance formula. So I'm going to go from 0 to -3. So 0 minus -3 squared plus, and then I'm going to go from 0 to 1. 0 minus 1 squared. And then CA, I'm going to use the 0 again and -6. Square it, and then I'm going to use 0 and 1, or 0 and 2 for A. All right, and then I'll just simplify that. And when I do that, 0 minus -3 is 3 squared, which is 9, and 0 minus 1 squared, that's negative 1 squared, which is 1. So we get 9 plus 1 is square root of 10. And then on the bottom we get 0 minus negative 6 squared is 36 plus 0 minus 2 squared is 4. 36 plus 4 is 40, so we have the square root of 40. That's the same as the square root of 1/4, which is the square root of 1 over the square root of 4, which is 1/2. So our scale is 1/2 here. All right, I'll let you try that. You can check back with your answers. All right, what are the images of the vertices of triangle LMN? For dilation with center 0, 0 and a scale factor of 2, graph the image of triangle LMN. All right, so what we're going to do here is we are going to first write down our dilation rule. Since our scale factor is 2, we know that each of the x coordinates, or each of the coordinates x and y, their image will be the rule 2 times x, 2 times y. So if we write down each of the points, m is 1, negative 2, L is negative 3, negative 2, and N is 2, 3. The image of those, we can just apply the rule. So we get the image of M is 2 times 1, which is 2, and negative 2 times 2 is negative 4. The image of L, we're going to double both of those, so we get negative 6, negative 4. And the image of N, we'll double both of those, we get 4, 6. And then we can just graph those. 2, negative 4, that's the image of M. Then we have negative 6, negative 4. That's the image of L. And we have 4, 6. That's the image of N. So we can just connect those. And we're done. I'll let you try that. All right, Jessica, I have a photograph that is 4 inches high and 6 inches wide. She wants to enlarge the picture by a scale factor of 1.25. What are the new dimensions of the photograph? So here's our original photograph. 4 inches this way, 6 inches this way. If the scale factor is 1.25, we can just use our rule. We're going to multiply both the width and the length by 1.25. And when we do that, we get 5 inches there for the width, and then the length is 7.5. So our new photograph is 5 inches by 7.5 inches. All right, lesson check. The blue figure is a dilation image of the black figure for dilation of center A. Two students made errors when asked to find the scale factor, explain and correct their errors. So the dilation is an enlargement. That's the blue one. That would be false. The side lengths of the black triangle are 6 and 3. That would be false. The side lengths of the blue triangle are 2 and 1. That's true. The scale factors between 0 and 1. That would be true because it's a reduction. And so the error they made, the side length of the black triangle is 8, not 6. So let's just say they made an error on the side length of the black triangle. All right. And solution B, the student thought it was an enlargement, or they did their math like it was an enlargement. And the correct scale factor is 2 divided by 8, which is 1/4 or 0.25. All right, that's the end of the lesson. I'll see you tomorrow.